Hi everyone, Brianna Denari here and welcome back to my channel. Have you ever wondered why butter at room temperature is a solid, but olive oil at the same temperature is a liquid? And what on earth is vegetable shortening? Today I'm going to answer all those questions as we dive into the fascinating science of lipids, aka fats. Lipids are a wide class of molecules that have a lot of really important functions for the way our bodies work, the way other creatures' bodies work, how even some non-living things work. Lipids are very important, and there's a couple of different types of lipids, and I'm going to provide a brief overview of them before we really dive a little bit deeper into a specific type of lipids that make up olive oil and like butter and more fats that we eat. So the first one I want to talk about is sterols. So sterols are a class of lipids that are in a ring-shaped structure. I am flashing you up a picture of a sterol right now. So these are the molecules are arranged in ring structures, primarily made out of carbon, hydrogen, and oxygen. And in all sterols, there is something called an alcohol group. And an alcohol group is what happens if you attach an oxygen to a hydrogen. So if you have an oxygen attached to a hydrogen, and that oxygen and hydrogen are attached to something else, that makes it an alcohol. So we have sterols. All alcohols end with an OL. Sterol, ethanol is the type of alcohol you typically drink, also ends with that OL, also has a little group of an oxygen and hydrogen attached to each other. A very common sterol that we're all very familiar with is cholesterol. Both for good reasons and bad reasons within our body, cholesterol is very important. The next type of the next type of lipid we're going to talk about real quick is phospholipids. So if you remember way back in our animal cell video we made, or even our plant cell video, we had to make a cell membrane for our cell. And the cell membrane basically collected the cell all together, separated like the inside of the cell from the outside of the cell, and let certain things go in and out of the cell. That cell membrane is made out of phospholipids. And the structure of a phospholipid contains a phosphate group, hence phosphate, which is based on the element phosphorus, contains a phosphate group attached to two very long chains of carbons and hydrogens that are called fatty acids. And I'll talk more about fatty acids basically right now, because the last group of lipids we're going to talk about is triglycerides. So triglycerides look like this, and I understand this is very complicated, so I'm gonna make it a teensy bit more simple right now. This is a model of what a triglyceride looks like. And a triglyceride is composed of a glycerol molecule, which is what this more or less is. It needs a couple more groups to be exactly a glycerol molecule, but this is basically a glycerol molecule, just a little bit modified for the purposes of this model. And this glycerol molecule is made out of carbon, which are these black atoms, hydrogen, these white ones right here, and oxygen, which are these red ones right here. So this is a glycerol molecule, and attached to this glycerol molecule are going to be three fatty acid chains. So a fatty acid has a oxygen and has an oxygen group attached to it, and then it's a long chain of carbons and hydrogens. And for, again, the sake of this model and the fact that I didn't have enough carbons and hydrogens to make this, we just have two. But there's one, which is two, where's my third one go? And three fatty acid chains attached to my glycerol molecule for 3-triglyceride. And these are the fats that olive oil and butter mostly contain. And these fatty acid chains can be very, very long, contain 20, 50, bunch of carbons. And how many carbons and how many hydrogens and all of that will affect some of its properties. So all all lipids have very similar properties because they're made out of the same kind of elements. So you'll notice here, we have red again as oxygen, carbons, hydrogens, and sterols and phospholipids contain those elements as well. So because of this, and especially because of these very long carbon and hydrogen chains with the fatty acids, Lipids don't like water. Think about it, oil and water don't mix with each other, and that's because these chains of carbon and hydrogen don't like water either. They're not gonna wanna mix with water. And then the shape of these also determine the physical properties of the fats itself. So let's take a look at something a little bit simpler. We're gonna take a look at one carbon with 4 hydrogens attached to it. Now this carbon is really happy in this state. Carbon loves to have 4 things attached to it, whether or not it be like 4 oxygens or 4 other carbons, or in this case, like I said, 4 hydrogens. It likes to have 4 things attached to it. It's what makes it really happy. So even if I were to, let's say, remove one of these hydrogens and attach another carbon to it, we have 2 carbons attached to each other, each with 3 hydrogens. They still have 4 connecting points. These carbons are very happy, they're very stable, they have enough electrons they need to make them happy. Because remember, electrons make everything be crazy if there's not the right number. And carbon is looking for 4 extra electrons, and it's getting that by connecting to 4 different things. Whether or not the carbon is happy with the number of bonds it has is what determines the difference between a saturated and an unsaturated fat, if you're familiar with those terms. So if we look at our fatty acid here, our triglyceride here, we notice that all of these carbons have at least 4 connections to them. So this carbon right here is attached to 3 hydrogens and another carbon. This carbon right here has got its attachment to another carbon, 2 hydrogens and another carbon. They all have the right number of carbons and hydrogens, or the right number of connections. And so does our molecule right here. So this is what is called a saturated fat. It means every single atom is happy, it's got enough hydrogens on it, it is all connected, it's very happy, it's saturated. And because of the structure of what a saturated fatty or triglyceride looks like, these guys are really easy. If you have multiples of these on top of each other, they're gonna stack nice and neat, and they're going to create a solid material. So butter is full of saturated fats. That's why it's a solid, because all of these guys are stacking nice and neat next to each other and creating a solid material. The stacking of these atoms and the structure of it will eventually affect the end product of what the solid material is going to look like. So if something is stacking nicely on top of each other, we're going to have a solid. Saturated fats are mostly solid or things containing a high number of saturated fats are solid because they are containing nice, easy, stackable structures. Now I'm going to demonstrate on this guy because it's a little bit easier to see, and I forgot my double bonds, so 1 second. I found my chemistry model kit and it made me very happy. So let's say right now we have 2 carbons and 6 hydrogens. They're very happy together. Let's say all of a sudden, for whatever reason, we lost some of our hydrogens. And now our hydrogens are like, what on earth is going on? So we lost 2 hydrogens. Our carbons now have missing spots. Let me put that back so you can see. So we've lost 2 hydrogens, and now our carbon each of our carbons is missing a spot. It's no longer happy. So one of the things that it can do is it can actually form 2 attachments between certain atoms. So in this case, between our carbon and carbon, we are going to form 2 connections, or a double bond. So now if we count the number of connections between our atoms, so for example, this carbon atom right here, 1, 2, 3, 4, it still has 4 connections to it, but 2 of those connections are between the same 2 atoms. But that's okay. They're still very happy, but even though it's happy, it doesn't have the same structure it did before. So an unsaturated fatty acid, or fat, happens when it's missing hydrogens. There's no longer enough hydrogens to fill all of the space. It's unsaturated, it's not saturated with hydrogens. And carbons start to form double bonds between each other, which result in a different structure. This different structure doesn't like to stack well with other weird structures, and so it's not a solid. It can't all pack in together. Instead, it flows like a liquid. Olive oils, vegetable oils, all very high in unsaturated fats, and that's why they remain a liquid at room temperature. If you were to decrease the temperature of that fat though, like putting it in the fridge, it would become solid because then those molecules, due to the cold, would pack together a little bit tightly. But at room temperature, olive oil is a liquid because it's really high in these unsaturated fats that are missing hydrogens, and as such have started to form double bonds between the carbons to make the carbons happy. Today we learned a little bit about lipids, about sterols, phospholipids, triglycerides, and how their actual chemical structure can impact their state of matter that we see, such as butter being a solid because it's full of all of those saturated fats, and olive oil being a liquid at room temperature because it's got a lot more unsaturated fats. Now, at the beginning, I asked you what even is vegetable shortening, and that leads me into today's fun fact. So, vegetable shortening is vegetable oil, which is an unsaturated fat that has had extra hydrogens added to it to make it become a saturated fat and therefore solid at room temperature. So hydrogenation is actually a process with which you can add at the end those missing hydrogens to make something a solid that once was a liquid. Pretty cool, isn't it? So we can manipulate states of matter that way. Anyhow, please be sure to drop that rating for the fun fact in the comments below. Like this video, please subscribe to my channel. I'm very grateful to all of those who have been watching. Share this with your friends. Please follow me on Instagram. I post about when videos are up are posted on YouTube. I post about various tiny little science adventures I go on outside of this channel. And please keep it sciencey. Sterols. So sterols are, lipids are very important. Now, when you have 4 different things all connected to one another, in this case for a carbon and hydrogen bond, we're getting what is called,